You know when you're playing a really fast-paced online video game,
Right.
and you perfectly line up a sniper shot on an opponent.
Oh, yeah.
You pull the trigger and you just completely miss.
Right.
And you're sitting there screaming at the screen because on your monitor you clearly hit them, but the game server just says, no, you missed, all because of lag.
Right, because you shot at where the opponent was a fraction of a second ago, not where they actually are at the exact moment you pulled the trigger. I mean, your screen essentially lied to you.
Yeah.
It presented a delayed packet of information as the absolute current reality.
Exactly. You're reacting to a localized, delayed broadcast.
Yeah.
Now, imagine that the server is the entire physical universe. And Albert Einstein's mind-bending rules of relativity, where time slows down and space physically shrinks, are actually just a byproduct of cosmic lag.
Yeah, it's wild.
That is the radical, fascinating claim made by the source material we are exploring with you today.
It really is a massive intellectual swing. I mean, the mission of this deep dive is to unpack a highly abstract, slightly rebellious physics blog post by an author known as Zynad 2023.
Right.
Specifically, we're looking at draft 127 of their work, which is titled Inclination of the X-Axis. And the author argues that the phenomena we usually associate with special relativity might actually be optical illusions.
Like a glitch.
Yeah, exactly. Illusions caused by a fundamental mapping error in how physicists draw space-time diagrams.
Okay, let's unpack this. Because if I'm listening to this right now, I'm probably thinking, are you seriously telling me Einstein was wrong because he just drew his graphs poorly?
Right.
Just to be crystal clear to you listening, we aren't presenting this as the new undisputed law of physics that abolishes a century of science.
No, definitely not.
Rather, we're exploring this author's incredibly detailed alternative framework for visualizing the universe based purely on information delay.
And to really grasp that framework, we have to look at the core sequence of how we as human observers or, even scientific instruments actually process the universe.
Okay.
The source outlines this strict 5-step sequence. First, an event happens out in the void.
Right, like a star exploding.
Exactly. Second, light from that event travels through space. Third, observation occurs when that light finally hits our eyes or our telescopes. Fourth, we form a memory of that observation. And finally, step 5, we do a reconstruction in our minds or in our physics textbooks of what the universe looks like based on that memory.
Event, light, observation, memory, reconstruction. I mean, that makes logical sense. So where does the author say physics goes off the rails?
Well, the problem starts at that final step, the reconstruction. It happens when an observer takes their own reconstructed memory, which, remember, is entirely dependent on when the light finally arrived.
Right.
And they treat those personal delayed coordinates as the absolute objective standard for the entire universe.
So going back to the video game, they basically treat their laggy monitor as the absolute truth of the central server.
Precisely. And to untangle why that causes so many mathematical paradoxes in physics, the source introduces what we can call the Mount Fuji problem.
Okay, I love this analogy.
It's a brilliant way to separate physical objective distance from the subjective experiential distance of, getting information across that space.
So for everyone listening, imagine you're trying to describe the distance between Tokyo and Mount Fuji.
Right.
Stating that the distance is 100 kilometers is an objective spatial fact.
Right.
It's a geometrical reality.
Yeah, exactly.
It doesn't matter if you're walking, driving, or if human beings don't exist at all, that space is 100 kilometers long. But if you tell someone that Tokyo to Mount Fuji is a 2-hour drive, or maybe a 20-hour walk, you have just introduced subjectivity.
Because that measurement of distance suddenly depends entirely on your method of travel,
Right.
your speed, the traffic on the highway. A 2-hour drive is no longer an objective fact about the space itself. It's a description of an experience across that space.
It's exactly like measuring a website's distance from your computer in ping time instead of server miles.
Oh, that's a good way to put it.
Like if the Wi-Fi in your house is really slow, the server feels further away. Your ping time might be super high, but the physical server didn't literally pack up and move further down the street.
No, of course not.
So is the author saying that modern physicists are essentially confusing the 100 kilometers with the 2-hour drive?
That is the core cognitive distortion the author is targeting, yeah.
Yeah.
Because in physics, we use what are called Minkowski space-time diagrams to plot out events.
Right.
And let's pause and actually define what a Minkowski diagram is, because it's kind of crucial here.
Yeah, give us a refresher.
Think of a standard graph you'd see in, high school math. You put physical space on the horizontal x-axis and time on the vertical y-axis.
Okay.
It allows physicists to map out where and when things happen in the universe.
Like drawing a map of the universe from a God's eye view.
Exactly. The author actually calls this standard diagrammatic approach the eye of the mathematician, or the eye of God.
Wow, okay.
Because it attempts to plot out objective space and time perfectly, as if you were, floating outside the universe looking down at everything happening instantaneously.
But the reality is, a human observer, or a camera, or the James Webb Space Telescope, we don't have the eye of God.
No, we don't. We only have the camera eye. We only have access to the light hitting our retina or our sensor at a specific moment.
We're experiencing the ping time.
Exactly. We are experiencing the travel time of the light. The source argues that when we take the standard Minkowski diagram and try to forcefully map our subjective light-delayed observations onto it.
As if they were instantaneous.
Yes, as if they were instantaneous physical realities. We confuse the travel time of the light with the physical geometry of space.
We confuse the 2-hour drive with the 100 kilometers.
You nailed it.
So, if the basic problem is confusing our local ping time with actual distance, that must create massive distortions when we look at things that are unimaginably far away, right? Like stars.
Oh, absolutely.
How does this actually play out when we look up at the night sky?
Well, the author gives us this brilliant visual thought experiment to prove just how distorted our perspective gets. Let's talk about the stargazer and the skylight.
Okay.
Imagine 2 stars out in the universe. At an absolute objective moment in time, let's call it copinet equals 0, those 2 stars are exactly 1,000 light years apart.
Got it.
That is a single objective fact in the universe. Regardless of who is looking, the physical distance between those 2 celestial bodies is 1,000 light years.
Okay, so that's our objective 100-kilometer measurement.
Right, but now let's introduce observers.
Yeah.
Imagine you are standing on a planet orbiting the star Betelgeuse, looking out at those 2 stars.
Okay.
From your specific local vantage point, the viewing angle between those 2 stars in the night sky might be, say, 30 degrees.
They would look fairly close together in your sky.
Right. Now, imagine you are standing on Earth looking at the exact same 2 stars at the exact same moment.
Okay.
Because Earth is in a completely different location in the universe, your viewing angle of those exact same stars is 45 degrees. They appear much further apart to you than they do to the observer on Betelgeuse.
And neither viewing angle changes the fact that the stars are physically 1,000 light years apart.
Exactly.
But it changes how the information is delivered to the observer's eye. And to make this really concrete for you listening, the source breaks this down using a Cartesian coordinate system, which honestly completely clarified this for me.
It is a phenomenal way to visualize it. So imagine you are lying flat on your back on the floor of a room.
Okay.
In our mathematical coordinate system, your eye is at the absolute 0 point. So x equals 0, y equals 0.
Right.
Directly above you, let's say 10 feet up in the flat ceiling, is a square skylight window. Let's mark that window's height at y equals 10.
Okay. I am on the floor. The window is 10 units above my face.
Yeah. The actual stars are way, way out in deep space. One star is at y equals 100, and the other is astronomically further away at y equals 1,000.
Okay.
But from the perspective of your camera eye lying on the floor, you don't actually see that incredible depth.
No, of course not.
You look up and you just see 2 points of light passing through that flat 2D window pane in your ceiling at y equals 10. And crucially, you see them hitting that window pane at the exact same time.
Okay, let me stop you there because this is the critical aha moment.
Yeah.
The light from star A, which is at y equals 100, and the light from star B, which is way out at y equals 1,000, started their journeys at totally different times in the history of the universe.
Right.
Star B had to send its light out hundreds of years earlier because it's 10 times further away.
Yeah.
But the cosmic lag perfectly choreographed it so both photons hit my eyeball simultaneously.
Exactly.
In my information space, the distance between those 2 photons at the exact moment they hit my eye is literally 0, even though the actual stars are vastly far apart.
Right. What's fascinating here is how the author insists we must strictly separate reality into 3 distinct layers to avoid going insane.
Okay, what is the layers?
Layer 1 is the real star surface. That's the origin point where the light actually began its journey out in deep space. Layer 2 is the window plane. So the y equals 10 mark, which represents our apparent celestial sphere, or basically how the sky looks to us flattened into 2D.
Right at the skylight.
And layer 3 is the camera eye. the observer on the floor receiving the delayed information.
Wait, so the author is saying that mainstream physicists are essentially confusing the flat window pane with the actual depth of the universe.
Yes. If you don't separate those layers, if you just collapse them into one mathematical graph, you start thinking the window plane is the real star surface.
Oh.
You start believing the sky is a flat dome exactly 10 units away, and that everything flashing on it is happening right now, instantaneously. You confuse the arrival of the mail at your front door with the exact moment the letter was written.
And when you ignore the window and treat the light arrival time at your eye as the physical truth of the event, our standard space-time diagrams create paradoxes.
Exactly.
The roads look warped. The universe looks like it's bending. So if standard Minkowski diagrams are creating a mathematical hallucination, how do we fix the map?
Well, the source proposes something quite radical. We have to drastically alter the space-time diagram to reflect the observer's reality, the reality of information delay.
Okay.
The author cheekily calls this a demonically modified Minkowski space-time diagram. Japanese, the term they use is Markuzu Minkowski Jikuzu.
The demonically modified map. I love the dramatic flair.
That's great.
But how does this modified map actually work? Like, what is different about it?
It works by taking the traditional spatial axes, the lines that measure physical distance, and converting them entirely into time axes based on the camera eye's perspective.
Wait, so space becomes time?
Essentially, yes. Instead of trying to map physical distance, like saying an event happened at the coordinate x equals 10 miles away, we map the delay of the information.
Oh, I see.
We record the event as the light arrived from an event that occurred 10 seconds ago, originating from the 0-degree direction.
Let me make sure I'm getting this. We are basically dropping a spatial dimension.
Right.
The author visualizes this by taking a segment of the x-axis, say, a straight line of physical space, and transforming it onto a complex space.
Yes.
Could you explain what a complex space means here, just for someone who hasn't taken advanced math in a while?
Absolutely. Think of a standard number line running left to right. That maps real numbers.
Okay.
A complex space simply adds a vertical axis, which is often called the imaginary axis. Now, imaginary doesn't mean made up.
Right.
It's just a mathematical tool that lets us plot things that rotate or have phases like waves. It basically gives us a 2D plane to work with instead of a 1D line.
Okay, so we have this new 2D plane.
The author takes that straight line of physical space and curves it into a semicircle on this complex plane.
Oh, okay.
But here is the genius part. The radius of that semicircle, the distance from the center to the edge, is no longer physical distance.
What is it?
The radius represents the time it takes for the light to arrive at the camera eye right at the center.
Here's where it gets really interesting. So you're literally graphing the lag.
Yes.
If a star is 10 light years away physically, you don't plot it at a distance of 10 miles or whatever. You plot it on a ring that represents a 10-year delay.
Exactly.
The further away an event is on the circle, the longer the information delay.
Yeah.
It's an inventory of delays,
Yeah.
not a map of physical territory.
That's a perfect way to put it. The angle on the semicircle just represents the direction you are looking. This allows you to perfectly describe the reality of the observer, the fact that light from different distances and different times is arriving simultaneously at the eye without having to warp the underlying geometry of the physical universe just to make the math work out.
This sounds incredibly elegant, but hold on. I have to push back here.
Sure.
Anyone who has dipped a toe into relativity knows that we have actual physical experiments that prove it works. We have subatomic particles in accelerators that survive longer than they should because they are moving fast. We have atomic clocks on airplanes that tick at different rates than clocks on the ground. Mainstream physics says this proves time physically dilates and space physically contracts.
Yes, that's the standard view.
How can this author just brush all of that off as a graphing error or like an accounting trick?
That is the ultimate test of this alternative framework, and it brings us to the famous Lorentz transformations.
Okay.
These are the daunting mathematical equations that Albert Einstein used to calculate exactly how much space contracts and time dilates. The author doesn't brush them off at all.
They don't.
No, they just offer a completely different, almost corporate explanation for what those equations are actually doing.
Corporate, what do you mean?
Instead of viewing the Lorentz equations as magical formulas that literally warp physical metal and slow down physical time, the author argues they are simply coordinate correctors.
Coordinate correctors.
Think of them as the math you use to convert global time zones.
Time zones. Like standardizing clocks across the world.
Precisely. Let's use an analogy. Let's say you have a global corporate public space. The Lorentz equation is just the mathematical operation you use to say, if the company master ledger says an event happened at 12 p.m. in London, what time should the local ledger say it happened in New York or in Beijing, taking into account the delay in communication?
But instead of physical cities, we're talking about different moving frames of reference in physics.
Right.
Like a spaceship flying near the speed of light versus a scientist standing on Earth.
Exactly. In relativity thought experiments, the source calls these the up-train local frame, the down-train local frame, and the track, or Earth frame.
Yeah.
To explain how we translate between these frames, the author uses a brilliant analogy based on ancient Chinese history, but applied like a modern corporate hierarchy.
Okay, lay it on me.
At the very top, you have President Liu Bang. He represents the absolute objective physical universe.
The CEO.
Right, he is the CEO who never leaves the top floor. His reality is the absolute truth. Below him is the managing director, Xiao He. He represents the universal physical laws, the underlying system holding the company together.
Got it. The objective universe and its laws.
Then below them, you have a department head known as the Train King, Han Xin.
The Train King?
Yes. The Train King represents the local administrator, the mathematics managing the shifting local frames, like a train moving near the speed of light.
Okay, well, I follow.
And finally, you have the regular employees who represent the individual data points or events we observe.
So why do we need the Lorentz equations in this company? Like, where do they fit in?
Because when you, as an observer, jump from standing on the platform to riding on the fast-moving train, you are effectively changing departments.
Right.
You are moving into the Train King's jurisdiction. Because information light takes time to travel between these departments, your local timestamps are going to look totally out of sync with the CEO's absolute master ledger.
Oh, because of the lag.
Exactly. The Train King has to run a complex payroll conversion to make sure your local delayed timestamps make mathematical sense against the global reality.
Oh, wow.
That translation software, IS, the Lorentz transformation.
So what does this all mean? Let me make sure that the listener's absorbing this, because this is the massive aha moment for me.
Yeah, go for it.
When relativity talks about a speeding train physically shrinking or time slowing down for a muon in a particle accelerator, the author is saying the physical universe isn't squishing like a stress ball in the hands of an angry god.
Right.
The muon's time didn't literally slow down. It's just the Train King, the mathematics, running a currency conversion on the timestamps. The Lorentz transformation is just HR doing a payroll conversion, so the local train's timeline matches the CEO's global space.
It is a profound shift in perspective. You aren't bending the physical company building.
Right.
You are just mathematically converting the timestamps on the emails based on which regional office sent them, accounting for the delay in the server.
That is wild. It totally takes the mysticism out of relativity and turns it into a problem of administrative lag.
Pretty much.
We have covered so much heavy ground today, so let's do a quick recap of this incredible journey through the mind of Zionad 2023. This deep dive has asked us to fundamentally rethink how we visualize reality.
Absolutely.
We need to stop confusing the time it takes for an image to reach us, the ping time, with the physical structural distance of the universe itself.
Yeah, we explored the skylight of our perception, demonstrating how our camera eye flattens the vast depth of time and space into a 2D window of simultaneous arrivals. We looked at how adopting a demonically modified diagram one that maps information delay rather than physical distance might solve the paradoxes of observation without needing to warp space.
Right.
And finally, we saw how the daunting Lorentz equations might just be the universe's ultimate time zone accounting software, reconciling local ledgers against a global reality.
It's a totally different, incredibly grounded way to map existence. But why is it so important that we understand this distinction?
Well, if we connect this to the bigger picture, outside of just theoretical physics, I think it carries a really vital lesson for our daily lives.
So?
You and I and everyone listening live in an era of unprecedented information overload.
Oh, for sure.
We are constantly bombarded with data, news, and images from all over the world arriving on our screens at lightning speed. It is so easy to fall into the exact trap this physics author describes.
Mistaking the local observation for the truth.
Exactly. Mistaking our local, delayed observation of an event for the absolute, objective truth of the event itself.
We confuse the laggy video game monitor for the server.
We do. Understanding the geometry of information delay helps us see past our own cognitive illusions. It reminds us that our perspective is always situated, always delayed, and never the complete, eye of God, objective truth.
Yeah.
It forces a kind of intellectual humility.
This is a really powerful takeaway. The screen is always lying to us, at least a little bit. Which brings me to a final thought I want to leave you with, something for you to mull over long after this deep dive ends.
Oh, I like where this is going.
If our entire perception of the universe is just a reconstructed memory built solely on the delayed arrival of light, then every single time you look up at the night sky, you aren't actually seeing a physical place. You are looking at a localized, heavily edited documentary of the past.
Wow. Yeah.
The stars are just a delayed broadcast.
Yeah.
But if that is true for the cosmos, what does that say about how we view the physical reality of the people sitting right across the room from us?
Right, because light takes time to bounce off them, too.
Exactly. The light bouncing off their faces takes time to reach your eyes. Even they are a broadcast.
Yeah.
Even they are on a delay. We're all just playing in the lag. Thanks for joining us on The Deep Dive.